So we have a new MLE object for sampling audio. We're calling it MLE.simpler. So it's a very simple sampler. So simpler is kind of a play on words for that. And to take a look at this, I'm going to go ahead and right-click this and open our MLE.simpler help file, which will show us a little bit more about how to use it. So here's our MLE.simpler. And just to make this a little easier to see, get rid of those guys. MLE.simpler, and here's essentially a little UI to access it. Now, before we get started, I want to mention a couple of quick things about how to load these MLE objects. So if I create a new patch, create a new object by typing the N key, and then type in MLE.simpler, there it'll go autocomplete, and I can just select it, and we have what looks like a regular Max object. But notice that this doesn't have this nice little user interface here that I'll be using in this help file. So the reason why is that if we double click this, there's where we'll see our user interface. Now, to be able to see that user interface within this level file, instead of just typing it in like a regular object, we have to place this object inside of a bpatcher. So bpatcher is a special kind of object that loads an object and then presents the user interface of that object to you, so you can see sort of what's inside this object, but up one level. So if I type in MLE.simpler here, now we're going to get our little user interface. I have to resize the bpatcher object so to be able to see what I have there. Conveniently, if you want to stretch this out, you can see what the arguments to this simpler file are, or you can hide all that stuff and just see the user interface. Let's take a look at these arguments for a second. So an argument, right, is a number or a word that you can type in after entering the name of the object, and that's going to set some basic parameters. For example, in MLE.simpler, the first argument is the speed of the sample. So an argument of 1 is going to play a sample back at its regular speed. Secondly, we can turn looping on and off. If you want just to have the sample play once, then you can turn looping off. If you want to have a sample play multiple times to keep repeating, you type looping on. Now we can enter the name of a sound file. If you want to load a sound file, Anton.aif is a sort of default sound file provided by Max MSP. Next, our fourth argument is a buffer name. So now the deal with this is that there are audio buffers in Max that store audio, and if you have one audio buffer with a name, you can have multiple MLE.simpler objects which reference that original audio. The idea here is that you don't have to load the same piece of audio multiple times if you want to play it back from multiple samplers. You can just load it once. We're going to kind of ignore that for now, and you just type anything you want here. It doesn't really matter what the name, what you type in there. As a matter of fact, if you don't type in an argument here, MLE.simpler will generate a random name for your buffer. But again, you shouldn't really have to worry about that much. And then the next two arguments are a number of subdivisions of the sample and whether the subdivisions get triggered on the beat. We'll see those in play when we start playing around with the user interface. So it's probably more information that you need to know about arguments for MLE.simpler than you really need. But I also want to make this point. So here I just typed those arguments in to a MLE.simpler object, just like any other object. I could type in a oscillator, or even better, a scale object, and type in some arguments for my scale object. And that would be sort of a normal way of creating a Max object. But because I'm loading this inside of a bpatcher, we can't just do the same thing. So in order to set arguments for a bpatcher, we have to select it, go to the inspector panel, and then go down to where it says patcher arguments right here. So now, if I go in here, and I can just type in the same arguments, and I'm not going to enter the buffer name at all, just leave it like that, save that, and now we've loaded Anton.aif right here, and we've set those options we defined using our arguments. Notice that the looping is turned on. If I go in here and I decide that the second argument, which is loop enable, if I set that to 0, well, it didn't turn looping off right there. But looping technically should be off. Let's see why that is. This is going to be a bit of a digression, but if you're interested in working and creating your own kind of objects like MLE.simpler, maybe this will be a little bit useful. So let's go ahead and put looping back on, Anton.aif. All right, so that was a long digression into arguments and creating Max patches. I might just chop that off and put that at the end of the video because you most likely will never need to do that. All right. So once again, we've loaded MLE.simpler. we've gone in here, we've entered some arguments to MLE.simpler. We've entered the first three, one which is the speed, the second argument is loop enable, and the third argument is the sound file to load. Notice this sound file can be any sound file you want to, but it has to be in your Mac's search path. So just like before, you have to make sure that whatever folder you save your sound file in is within this search path that you've already set. All right, so now that we've got that in place, we can go ahead and take the output of this object, which is right here, audio out. I'm going to make an easy DAC, easy DAC. I'm going to make my standard volume control. Connect the output of that to the left and right output of our DAC. And I'm going to start playing this sound file. So make sure my DAC is turned on. And I should start seeing audio. Turn my volume up. I should start hearing something. All right. So we can do a bunch of things just directly in the interface right here. We can change our playback speed. We go reverse, which is kind of nice. Obviously very slow. Kind of fun. This particular sound file is a lot of fun slow, actually. We can stop playing. We can turn looping off. Now it's stopped. In order to play it again, you have to re-enable. Turn looping back on. If I want to load a new sample, I can just drag an audio file right there. So here's my audio files. If I go down here, there's my Anton sound file. I'm going to drag in a Bulgarian sample. Oh, it didn't find it because Max can't find all my samples. Let's go down here and let's choose vibes. All right, so here's a vibe sample. This is another one of the default Max MSP sound files. If you try dragging a sound file in from here and it doesn't work, it's because Max is having a hard time finding that path. If I look over here, it's going to tell me, whoops, I'm not able to find that sound file. So here's my vibe. I got looping on, so it's going to keep repeating. So let's try something. I'm going to mess around with the number of divisions. So what this is going to do is it's going to chop our sound file up into segments, and it's going to give me the ability to loop and play each segment individually. So right now there's just one division, so if we just divide this into one long sound file, it's just the single sound file. If I increase my number of divisions to 2, alright, so I'm going to load in my vibe sample. It's going to give me my loop start point and my loop end point, so this is basically how long the sample is. Now if I play it, I can just hear my vibes. If I change the number of divisions, what I'm going to do is chop it into half. I can play either half. So there's just the second half, there's just the first half. There's 4 halves, 8 halves. So that can be really fun to play around with, depending on what your sound file is. So notice I can load a sound file here just by clicking on it. So I'm going to load on here, go to some sound sets. I'm going to choose a singing sample. I think this is pretty fun. Go there. I'm going to set it to a large number of subdivisions. So not quite 100% perfect, but pretty close and pretty fun to play around with. So we do have another file, a help file, to show you how to use the MLE.simpler. So this basically gives you a guide to the inlets and outlets of this file. So the first thing we can do is we can put in a replace message. So here I just replaced our sound file with a drum loop. I'm going to turn this drum file on. All right, so that sounds pretty straightforward. Again, if I set my number of divisions to 8, divide on the beat, let's go ahead and do 4 beats. So fun to play around with. let's take a look over here. Let's take a look at these inlets and outlets. So the first inlet is just a inlet for enabling or the sampler or replacing the drum loop. So if I send it a toggle message, that's just going to be the same as clicking this. So if I put a 1 in a message box right there and click it, I can re-trigger my sample. All right, so that's pretty useful. Similarly, if I want to replace a sample, I can just click this button. We can click this button to manually find a Finder window, or this button to replace a sound file. Second inlet, this is for the speed. So if I connect I'm not going to do an int, I'm going to do a float. Here, it's just exactly the same as the playback speed here. All right, so next inlet is the number of subdivisions. So again, the same as that. Then the current subdivision, which is the same as this. And the last inlet is whether we're going to trigger on the beat or not. So the same as that. So we can control these things from outside. What this lets us do is do something like a random object. This is a drunk object, which is actually doing a drunk walk. So it's going to sort of randomly choose things within a very narrow range and kind of gradually move that range around. And my metronome is just going to trigger this every 200 milliseconds. So I'm going to turn this on, set my number of subdivisions to 16. So here I can set my number of subdivisions and the range of my drunk object at once. So very fun to play around with. So notice I'm only triggering the sample change on the beat. If I turn this off, it's going to change it much more quickly. All right. So we can also use this as a more traditional sampler by loading in a sound that's just like one sample of a note and using a MLE.seq to sequence a bunch of pitches. Now we can actually just send any number we want to, any MIDI number, and convert this to the right format for triggering a sampler by using an M/S object. Just playing a chromatic scale up and down using our sample. Notice that the slower the sample gets, the longer it is. The higher a sample gets, the shorter it is. This is not a great sample because it actually doesn't ring for the whole sample. It ends too quickly. Kind of cuts off unnaturally. That's just the sample itself is recorded too short. This MLE.seq object, here I have, again, it's in a bpatcher. So I made a bpatcher, typed in MLE.seq. At this point, I could go into the seq object inspector and enter in some arguments. Like, for example, I could say I want my seq object to have 16 steps rather than only 8. Or I want to edit it so it has 16 steps and a possible range of only 5 values. So now I've got 16 steps, but only 5 possible values for each step. So you can edit that using the argument right there. You can also create a MLE.seq like that and do the exact same thing. 16 steps with 5 values. Double click on this, we'll see the user interface looks exactly the same. If we're curious about what those arguments are, we can go in here and we can take a look at the arguments. As a matter of fact, I'm going to go ahead and add this to our presentation mode so we can see it from here. And that way, when we have it in our bpatcher, just take a look down here, we'll see what the arguments for MLE.seq are. The number of steps in the sequencer and the number of possible values per step. So that's this, 16 steps, 5 possible values. All right, so here we have our MLE.seq. It's got 8 steps with 8 possible values per step. I can step through those just by using a counter object. The counter object is just going to count from 0, in this case 0 to 6, because I think or 0 to 7. The counter object is inclusive. So if I turn this on, 0 through 7 is the maximum step. And stepping through our sequence. Obviously, we can make a melody. We can also change the playback range. So just like we would with normal use of MLE.seq, we may go backwards by setting the start point be after the end point, and then just keep changing our sequence values. Kind of fun to play around with. All right. So we have our output of our sequencer going to a scale object. So this takes the incoming values and maps them to a range of possible outcoming values. In this case, it's looking for 0 to 16 and mapping 0 to 32, 16 to 60, and in-between values to in-between values for here. So we only have 8 values right here. Let's go ahead and make this have 16 steps and 16 values. And now we can make more complicated melodies. And change our counter to count. So actually what's going to happen here is that our counter is going to count from 0 to 15 inclusive. And actually we've got 16 steps here, but we start at 0. We're 0 indexed here. So our first step is actually step 0. So our 16th step is step 15. So counter 15 will actually get us where we need to go. If you ever get curious or confused about what's going on here, just monitor the output of this. Make an int box, throw the output of counter into that int box. Whoops. Let's actually get to the output of counter. And we can tell what's going on here a little bit more easily. So you're going to go all the way up to 15. So now we've got a little more room. Some of those low values are kind of a little bit awkward, huh? Let's make the possible range be higher. Like say 40 to 72. All right, and then we can also play around with these values. And notice our inlets here for our end step and our start step means that we can automate these values using something like a drunk object. So kind of fun way to make some generative melodic kind of sequences. So just another quick word about what's going on here with the m/s object. Let's remember a couple of details. First off, what we have right here is a MIDI note. So this is a note value, just like a note on a keyboard, where each value is a chromatic step up and down. What we need for our sampler, unlike for a oscillator or a synthesizer where we need a frequency, which is a number of cycles per second, our sampler needs a value that's normalized where 1 equals playback the sample at the normal rate. So there is our default rate for our sampler. If we want to go down an octave, we have to slow the playback speed down by half. When we go up an octave, we have to double the default playback speed to 2. So the playback speed is very different than hertz for a synthesizer. So the m/s object converts the MIDI note into the correct playback speed to get the pitches that we want here. But in order to do this, we need to know the frequency of our sampler. So this value right here is the frequency of this vibraphone sample. So we've actually got 3 different values going on here. The MIDI note, which is like the piano keyboard, the actual frequency in terms of like the frequency of the pitch that this MIDI note is, that this sample is playing, and then the normalized playback speed in order to get the sample to play back at the right pitch. So it's a little bit tricky to get that all set up, but once you have it in place, it is pretty easy. So what I did here is I took my sample, I played it back at default speed, put it on loop, and then I made a cycle object, which is just a sine wave oscillator, and put that in here, and gave it like a default value, and then looked for tuned it kind of like I would tune a guitar, right? Just like listening for it to hear where it's in tune. It's a little bit hard to hear sometimes with just a sine wave. You can also use a triangle wave. Might be a little bit easier to hear. You can hear that's really in tune. That's pretty out of tune. That's flat. You can hear the beats. So once you know the value, the frequency, just type it into M to S as an argument, and you're good to go. And then you can play your chromatic scale. All right, so remember this MLE.simpler file is a max help file. So I'm not going to save that because I don't want to overwrite what's already in here. But once I have an MLE.simpler object, just right-click it, open MLE.simpler help, and here's our MLE.simpler file. If I did want to use this as a example, something to build on, I can just unlock it, copy everything, make a new patch, paste it in, and now I can do whatever I want to with this and cut and paste and sort of, connect things, no problem, and it's totally fine. So I'm going to open up my MLE.simpler original object. So here is that UI I have. Now I'm in presentation mode, so that means I can take all of my user interface elements and organize them really neatly so they look really nice and compact. If I leave presentation mode, I'm going to go back to more traditional max patch structure, and again it looks kind of like classically kind of complicated, right? So in my situation, that's why. Oh, that's tricky. So what's going on here is that I have these init objects. These init objects are used to set arguments. So every time you want to have an argument for like MLE.simpler, this init object is what actually lets you type that argument in and then recognizes it and sets the correct parameter when the patch loads. So our first argument, number 1, is playback speed, and our default value for playback speed is 1. So if you don't type an argument in, if you just type in MLE.simpler like that, no arguments, it's going to have a default speed of 1. And that's what this object does, is it basically says if there's an argument, then we're going to set the argument. If we don't have an argument, we're going to give it a default value. Similarly, with looping, if there's an argument, we'll set that argument. If there's not an argument, then we'll give it a default value. Now, the tricky thing with this is that if you don't give an argument here, then the value it gives you is 0. So essentially, if you leave an argument blank, right, then Max will replace that blank argument just with a 0 and say, oh, there's no argument, it's just a 0. And in here, what we're doing is we're loading that argument, and if that's a 0, then we're saying, well, no argument was initialized. We didn't give it an argument, so we need to go with our default value. The problem here is that we want our argument to be 0. We're specifying that our argument is 0. So if we say, okay, we want our argument to be 0, this patch still thinks that no argument has been entered, because 0 to this object just says no argument. It can't recognize the difference between an intentional 0, like I want the argument to be 0, and an unintentional 0, meaning I didn't enter an argument at all. So because of that, this argument will never work, and our looping will never get set to 0. So that's actually a problem. And I don't have a good solution for that right now. One solution for it would just be, okay, you know what, the default argument is going to be 0. Looping is going to be disabled by default. And actually, that's not what's going to happen right now. I would just change this here and say here, now our default value is 0, and if we want looping to be on, we will have to manually tell it to be on. So here's our MLE.simpler. Go in here, edit the argument for the second argument, which is loop enabled. Edit to 1, loop is enabled. Go in here again, do the same thing, return loop enable off, no loop enable. Go in here, get rid of these arguments. So there's no arguments at all. Looping will still be disabled because our default value for looping right now is 0. So I guess we're just going to have to do that.